So I can't screw this up because all my video recording eggs are in this basket. So Louis, since you're the one that always reminds me to record, if you see me push pause, you got to remind me to record again. Got it? If you're uncomfortable with that responsibility, designate a second who can help you out, just like in old duels. All right, so we talked yesterday about functions and relations. Functions and relations are simply the comparison of two different sets of information. The information I started with was dog type and the height of the dog. Each dog type is a piece of data. Each dog type compares to a height for that dog. Therefore, we had a relation. Some relations are special. They are functions. The difference being, in a function, everything from one set relates to one thing in the other set. Okay? And only one thing. Alright? There's tons of examples in your notes. The video is up. You should check it. Most people are okay with that part of yesterday. Right? Most of you. Where yesterday starts getting confusing is when we started talking about independent variables, dependent variables, domain, and range, which is what I'm going to review now in a second. We're going to start with that. So I had the independent variable. You do not need to write this down. You already have it written down. You might want to just pay attention. Or you may want to write it down. That's up to you. Now, I explained the independent variable as the variable that doesn't change. It's the thing that is the same for everyone, right? That's how I like to remember it. If you have trouble remembering which is which, think about it this way. If you weren't doing a math problem, but one of the variables applies to you, that's the independent variable. Okay? So, let me show you what I mean. If I were to compare my age and my height, right? Which of those two things applies to you? I'll say it again. My age and my height. Pretend I'm in the 10th grade with you. Do we share an age? Yes. Do we share a height? No. So which is the independent variable? Everybody understand? I work at Subway. I get paid $10 an hour. You don't work at all. Do you share an hour with me? Hours aren't passing for you. You've stopped time. Do you share the hour with me? Yes. Do you get paid for that hour? So what is the independent variable? The hours. Everybody understand? It's the one that's always there. Okay? I don't know how else to explain it. I've tried to explain it with math words. I've tried to explain it with examples. That's all I've got. Everybody okay with it? Yeah. All right. So the independent variable, I like to remember it as the one that applies to all. Now there's some rules about the independent variable. 1, 99% of the time we graph it on the x-axis. Almost always. Okay? Everybody with me? Actually, that's really the only rule that needs to be talked about there. The other one is the dependent variable. And the dependent variable changes when the IV changes. So think back to that job one. One variable was the hours. One variable was my pay. If the hours do not change, does my pay change? No. So pay depends upon the hours. Does everybody understand? If time didn't go on for me, would I have gotten any taller? No. And now that I'm 43, as time goes on, I am starting to get shorter. I have lost a ½ inch in height in 10 years. Okay? Everybody understand? All right. The dependent variable, again, 99% of the time is on the y-axis.
And what's the 1%?
I'm about to show you. Don't draw this unless you need to. You guys have already seen the hound or the dog type and the height of the dog graph, yes? Yes. We had dogs down here, hound. We had height here. The hound was 60 centimeters, yes? The height depends on the type of dog I am speaking of, correct? If I asked you, what is the height of a Pomeranian? Could you do that with this graph? No, because you don't have a Pomeranian to give me a height for. Understand? Now, Louis, let's say I have this graph, but it doesn't fit on my page. I'm trying to create a poster or something. So I turn the graph sideways. Hound, height. And I go this way. Hound is still the independent variable, even though it's on the y-axis. You understand? It's a publishing thing. The problem is, as soon as I say the independent variable is the x, everybody doesn't hear the definition of independent variable. They hear independent variable is x. See the difference? Okay. Everybody good there? All right. Now, the independent variable, oops, I didn't want to do that in blue. I wanted to do it in black. The independent variable will always have some values, won't it? Or you don't have an independent variable. You have to count something, correct? Those values make up the domain. So in the dog one, all of the types of dog were the domain, because that is all the values that are associated with the independent variable. So it doesn't need to be a number. Everybody cool? The values make up the domain. The dependent variable also has values. Those values make up the range. All right? Is everybody good to there? Okay. We threw out some other words yesterday. We talked about input versus output. Input is what you start with. Output is what you get. Right? So if I give you an input, that is your independent variable, because that's where you're starting from. Think of that graph of dogs. If I don't say the name of a dog, is that graph useful to you? No. So I had to input the name of the dog that I wanted the height for before you could tell me the height, correct? So the input is the IV. The output is the DV, which means all these values are what? Domain or range? Domain. All the inputs are domain. The output is range, which means all of the DV values are range. Everybody good? What? What don't you understand? Oh, I'll get to that. I'm about to get to that. Okay? Now, what if you are given this, some number and another number. Where have you seen that before? It is the graph, yes? And this first number is what? The x. And the second number is y, correct? Okay. How would you go about finding this spot on the graph? What would you do? On which axis?
The x-axis.
So you'd go out 2 and then where?
And then you go down 7.
Down 7.
Negative.
We all started with 2 because it was x, right? That is our IV, our input, and it's a domain value. Everybody understand? Which means 7 must be what? My dependent variable, my output, and my range value. Everybody good? Okay. That is -2, -7. Everybody cool? All right. Now I'm going to put another dot on here at 2, 1. 2, 1. What is this? That is an input, x, and domain value. What is this? A dependent variable, a range value, an output, and a y. Correct? So now I have 2 dots. What is my domain for this graph that I've just drewn? What is the domain of the graph I just drew? -2, because it's -2 on the x, and +2. That's the domain. Everybody with me? Okay. What then is the range?
Does it matter what one you put first?
You always put the lowest value first. Okay. Is everybody cool with that? Okay. Why did I write it this way? Because there is only an input of -2 and an input of +2. Does everybody understand? What happens if I make this line here? Now, do I have inputs all the way along? I do, don't I? Does everybody understand that?
Why
So,
do you have it all the way around?
because I have, what is a line? What is a line? It's a series of dots so close together they're touching, right? Each of those dots has an x and a y, don't they?
Yeah.
So if I put a dot right there, that dot has an x and a y, doesn't it? When it's on this line. So that means there's an x value there, and there's a y value there, correct? And because it's a solid line, there's an x all the way along. I can choose any number from the x-axis between there, and I will get a y value, won't I? Do you understand? Just say no if you don't, Ash.
No, I don't.
Okay. I need some graph paper then to do this properly. What is that point right there? -4, -2. Agreed? Because when I go out to x that is 4, -4, there's a y value of -2. You understand that, right? Everybody understand that? Okay. What is this one here? 3, 3. Because when I go out to 3, I go up, I've got a 3. Cool? All right. Now, what about... oops, sorry. Now, I have put a dot right there, yes? What is that dot's value? It's not quite. It's in the middle, right? So it's negative 1/2, right? And positive 1/2. Are you cool with that?
Yeah.
Okay. So now, what are my range values? Or my domain values? They're the x's, right? So it's -4, -1/2, and 3. Cool? And the range values are -2, 1/2, and 3. Cool? Because that dot is there, it's got an x and a y value, yes?
Yeah.
Okay. Does that dot have an x and a y value? Yes. Does it matter what it is right now? No. Does that dot?
Yeah.
Does that dot?
Yeah.
Does that dot? Does that dot? Does that dot? Does that dot? Does that? They've all got x and y values, right?
Yeah.
So if it's a solid line, then isn't every single spot on the x-axis going to be represented by that line? Do you understand now?
Yeah.
Okay. So if it's dots, my ranges and my domains are just the points. But if it's a straight line, then it's all of these x's. Got it? So it's not -4 and 3. It's -4 all the way up to 3. And we write that with math symbols. -4 is less than or equal to x. All my x's, -4 is the lowest x can go. +3 is the highest x can go. That's why we write it that way. Since math guys are lazy, they don't like to write that many symbols, so they invented this. -4 with a square bracket, because it got all the way to -4, up to +3 with the square bracket, because I got all the way up to +3. If this was an open circle, we would change these, and I'm about to go over that right now. But do you understand why we go from dots, numbers, to a spread? You good?
Yeah.
Okay. No problem. Okay, so everybody's cool here now, yes? When I change this to a line, this doesn't become squiggly brackets, comma, comma, because it's all the values in between, right? So, the domain, when I made the gray line, became -2, less than or equal to x, less than or equal to +2, which means all the x values in the middle. All right? If there's an equal sign, we put a closed dot. If there's no equal sign, it's an open dot. Everybody good? And range would have been -7, less than or equal to y, less than or equal to 1. And again, open dot is less than, closed dot is equal to. Open dot is less than, closed dot is equal to. And then math guys added the last move. If it's an open dot, we put a round bracket. If it's a closed dot, we put a square bracket.
And the dots are determined by what's on the graph.
The dots are determined by what's on the graph. If this dot here looked like this, an open dot, then this line would be just the less than sign, no equal. And we would put a round bracket by the 2. Is everybody good? That's everything we did. And yeah, it only took 10 minutes today. Because without examples, it's easy to talk about.
What does that mean to on the side?
I'm sorry, what?
That mean to.
I don't know. Let's find out. It's some math I did, and the x and the y would have been the first thing I wrote, or that. And that's what the computer thinks that says. All right. Is everybody feeling okay? Now, I gave you no work, so here's what we're going to do. Turn the page over. You're going to work on page 147 in class. Now listen to me. The answers are there. Be smart. Cover them up and try it first. We are going to go over all of page 147 in this class today. Class is over in 20 minutes. 148 is the exact same stuff, except instead of listing points, they put it on a graph. It's the exact same stuff. And then I'm going to show you what I want you to do with 149 and 150. Okay? Everybody with me? All right. Take a few moments right now and start on page 147. If I were you, I would do C and D if I was only going to do some of it. I would do all of 8 and I would do all of 9. I think that should take about 10 minutes. After 10 minutes, I'm going to go over them and I'm going to show you how to do 149 and 150. Okay? Go. I'm going to do all these because it doesn't take any amount of time. What are my x values in A? 1, 2, 3, 4, yes? So those are my domains. 1, 2, 3, 4. I have to write them all because I've been given them as set points. It's not a line. Cool? What is my range? 3, 6, 9, 12. Oops, that should have been a squiggly bracket. Everybody good? Is it a function? Yes. Because every time I choose an x, I get a new y. Everybody with me? Look at the second one. My domain, 1, 0, negative 1, 0. So my domain is 1, 0, negative 1, 0, 1. Yes?
Does that have to be in that order?
You put the lowest one first. Range is negative 1, 0, 1. Now, is it a function or relation? Look, 1, 0. When I input 1, I get an output of 0. That's okay. When I input 0, I get an output of 1. That's okay. When I input negative 1, I get an output of 0. No problem. But here I input 0 again, and I get a different output than the last time. So the input of 0 did not give me a unique output, did it? Because when I choose 0, I could be at 1 or negative 1. So this is a relation. Everybody with me? Now there's the two you did. 2, 4, 6, 8. 3, 5, 7, 9. Every input gave me its own output, so that's a function. Now look down here. 0 gave me 1. That's okay. But then 0 gave me 2. That's not. And then 0 gave me 3. So there's 3 possible y values when I have x. There's my graph. 0 is right there for x. I could have been 1, 2, or 3. That's not allowed. Because you don't know what output I am speaking of. So that one is a relation. Everybody good? Same thing down here. Easy peasy. The domain 1, 2, 3, 4. The range 1, 8, 27, 64. Function. Because every time I put in any value, I get a different output. What about down here? Relation. Because 3 got me 4, then 3 got me 5, then 3 got me 6, then 3 got me 7. So if I graphed it, x is 3 right there, 1, 2, 3. The dots are at 4, 5, 6, and 7. Which dot am I thinking of when I say go to 3? You don't know, so it's a relation. Is everybody good? All right, now, number 9. This one's slightly harder because I also asked you to tell me the IV and the DV, then tell me the domain and range. Remember, I gave you the definitions. If we weren't doing math, and I go to 7-Eleven and buy this can of juice, do I have a can of juice in my hand? Yes. I then go to Costco and buy the same can of juice. At one place I paid more than the other place, didn't I? The pay depended on where I bought the juice. I still have the same juice, but one costs more than the other. So the number of cans of juice is the IV, the cost is the DV. And it's a function because every time I get another can of juice, the price goes up. And they're never going to be the same. If I buy 5 cans of juice, I'm obviously paying more than if I bought 4 cans of juice. Everybody understand? So that is a function. This is the domain. This is the range. Let me ask you this. Could I write this domain like this? 1 less than or equal to cans less than or equal to 6. Could I write that? Yes or no? No, why not? I can't buy half a can. I can only input whole cans. Everybody with me? So I would have to write 1, 2, 3, 4. I can't do that one. Same with range. Everybody cool? Now go to the last one. Altitude, temperature. What depends on what? Temperature depends on the altitude, which is why on top of Mount Baker, even though it was 30 degrees here last week, what's on the top of Mount Baker still? Snow, all year round, because temperature depends on altitude. That's why you got to know the definition, right? So what would now this is trickier. What's my range here? Or my domain, I mean. 6, 10, 12, 20, this is it, right? Could I write it this way? Altitude, 36, 60.
Yeah.
Why?
Because it ranges from anywhere from 610 to whatever it is.
I do not stand on a mountain at 610 meters above sea level, right? And then disappear and show up at 1220, do I? To get to 1220, I would have to go through 611, 612, 613, 614 with me. So in this one, I can do this because I can have partial values. Everybody understand? What about this one? Could I do my range the same way?
Yeah.
Negative 4.8 to 15, and I could do this with temperature. Everybody cool? All right. Okay, you make me happy. This page is the exact same, except they're on a graph now, right? So this first question, since it's all dots, is exactly the same as question 5 on the page before, except instead of giving you 2, 4, they put it on the graph. Everybody cool? If you're 100% okay with page 147, you can be cursory with 148. You can just give it a glance. Okay? But I do want everybody to come down to this page. I'm only going to do 2 and 3 because they're the hardest ones. Okay? Domains will be in blue. Ranges will be in red. Domains are where? X or Y? X. So I have to go to the lowest X value. Where is the lowest X value? On the left or the right? Left. So I go out to here. What is that value? -4. Agreed? Is that dot colored in? So is -4 included? Yes. So I write with an equal sign. Now, since this is just X and Y, my domains are just X's and Y's, correct? Now, Ash, is there an X value all the way along to here? Yes. So, this whole bit is X value, yes?
Yeah.
What does it go up to?
+2.
+2. Is that a colored in dot at 2?
Yeah.
Yep, so 2 is included. Everybody see it? Now write it the other way. 4 is included, so it's square bracket negative 4, square bracket 2. Everybody good? Now, what do you do for range? The exact same thing, except it's on the y-axis. So I go to the bottom. What is that? Negative 1. Right? Is that colored in? It's hard to see, and I'm going to talk about that in a minute. We're going to say that one is colored in. So it's negative 1 less than or equal to what? What are the values we're counting now? X's or Y's? Y. And I go up. When do I stop? Right there at 5. Did I make it to 5? Is it a closed dot? Yeah. 5. And then I rewrite. Negative 1, comma 5 with square brackets. Is everybody good with 2? Okay. That's going to be the same. Now, look at 3 and tell me what's different. What do you see that's different on 3? The lines aren't straight? Where? Oh yeah, it should have been negative 3, not negative 1. Okay, there's an arrow. What does the arrow mean? It goes on forever, right? But you can see it flattens out, yes? So let's start with our x's. What's my lowest x value? Go along the x-axis till I run out. Right there, what is it? Negative 1. Is that a closed dot? Yep. Negative 1x. Now, what do I go up to? Infinity. Right? Will I ever get to infinity? Do you ever get to infinity? No. So can it ever equal infinity? No. So it's just that one. No equals. Which means it would be square bracket negative 1, infinity, and then what bracket? Round. There's another way to write this. X is greater than or equal to negative 1. Because every x value bigger than 1 works, because this is going to go on forever. Everybody cool? Everybody good? Okay. What about the range? What's my lowest range value? Negative 3, because that's where it flattens out, right? So while we're waiting for this to thaw, you guys should be trying to figure this out. Negative 3, and I got to negative 3. Why? What do I go up to? The highest point on the graph. Not the dot, the highest point. And it is what? 5. And then I rewrite. Negative 3, comma 5. Both with square brackets because I hit them both. Does everyone understand? Yes. Now, the photocopying, as Louis pointed out, is pretty crappy. On number 4 on the first page, this is an open dot. It's quite easy to see on my screen, but I don't know what it looks like on yours. So somewhere you might want to put the left one is open. The right one is closed. On number 5, you can see that's supposed to be an arrow. Everybody okay? Turn the page over. On number 2, this one is open. I'm drawing a big circle around it to show that it is open. This one, number 3, has an arrow. Everybody still okay? Number 4, open, 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 with 2 arrows. And number 5, open at the top. Is everybody good? Try them. You know you're going to see the right answers tomorrow. Does it do you any good to leave them blank? No. Try them. Because it doesn't hurt you to get it wrong either. Okay? Remember, cumulative is Thursday. We're going over this tomorrow. Then we're going to move on to the next lesson in functions. They will not all be like this. It will not be teach, bell, and then work the next day. That was only for the first day because there was so much stuff in that first day that you'd never seen before with all the new words. Unless you were in my grade 9 class, I try to prepare you for it by talking about independent variables and things. But I don't think any of you were in a grade 9 class with me, so you're screwed. Well, not really, because now we're caught up.
Yeah.
Okay? Okay.